Welcome back to part 2 of Module 5, or Module 13, Lesson 5, where we're going to do congruence and transformations. For this one, we're going to start off at extra example number 1, and you have a mission of trying to find out whether or not these two figures are going to be the same. So we've got a number of different things that we can do. We can do a translation, we can do a reflection, we can do a rotation, and last step, if nothing else works, do a dilation. But if you do a dilation, at that point we know that it's not going to be congruent. Go ahead right now and start working on this and then see what you come up with. Now, first thing I see when I look at this is that I thought, we could just take and do a rotation around, but a rotation isn't going to work. I'm going to need to do a reflection because of the angles of these pieces here. So my first move is to reflect it. I'm going to reflect it across the horizontal or x-axis where the y value is going to equal to 0. And when I do that, I'm going to do a vertical reflection. Hold on, something's not working right. Alright, I was looking at the wrong triangle. It did reflect across the x-axis here. We started with ABC, now we're on A prime, B prime, C prime, and now I need to translate it. So I'm going to add a transformation. I have to go 1, 2, 3, 4, 5, 6, 7, 8 positions to the left. So I'm going to do a translation, and it's going to be a horizontal translation of -8. Whoops, too far. And right there, it maps perfectly over our other triangle. So because of that, we can take and finish answering the question here. Are they congruent? Yes, they are congruent. And then you could even write a nice statement about the translations that you took place, saying that you reflected it across the x-axis, and then you translated it 8 units, I believe it was, to the left-hand side. Yep, that's all there is to doing these. Next, we're going to take a look at example number 2, which wants to know, are these two figures going to be congruent? And if so, we need to figure out a sequence of transformations that maps the trapezoid EFGH onto trapezoid IJKL. So we're going for the blue, and we want to move it onto the green one. Hopefully they'll give us more cool toys like they did last time, and they absolutely do. First thing they did is they reflected the trapezoid across the y-axis. Yep, I can see doing that. So we're going to take it. We're going to go a reflection across the vertical axis, the y-axis right here, where x is equal to 0. And now you can see my new trapezoid is going to be this one right here. After that, what do I have left to do? I've got to move it up. So I'm going to translate it up 1, 2, 3, 4 spaces. I'm going to add a transformation. I'm going to do a translation of a vertical +4. And when I did that, oops, what happened? They don't match up. 3 of my points matched. 1 of my points do not match. And because that 1 point does not match, we can say now that these two are not going to be congruent. But wait a minute, something happened here. Yes, the orange one is going to be the translation. The green one was the original. They're two different shapes. They are not going to be congruent. From here, we can take and move on to finishing up the rest of the question. Is there any other questions there? Nope. I guess we can just say that it didn't work. Easy math. Now it's going to be your turn. Go ahead and stop the video. Work extra example number 2 on your own. How did it go for you? When I'm looking at it, I think the first thing I want to do is flip triangle ABC across the x-axis, the horizontal axis. So I'm going to start with a reflection or a flip across the horizontal axis, and you can see that happen right here. Now I need to slide it. So let's go 1, 2, 3, 4, 5, 6, 7 spaces to the right. So I'm going to add a transformation, and this one is going to be a translation where I'm going to do a horizontal slide of 8 spaces. And when I do, what do we find? We find that our two triangles are not going to be congruent. So from here, we're going to scroll down, and we're going to say that the triangles are not congruent. Check our answer. That's all there is to do in these. Next, we would like to take some time identifying some transformations. The order in which the vertices of a figure are named determines the figure's orientation. In the reflection shown, the vertices of the pre-image is a in the reflection shown, the vertices of the pre-image are named in a clockwise direction, but the vertices of the image are named in a counterclockwise direction. That means that the orientation had been reversed, so that we didn't just slide it over. Your letters, the order the letters came in, was reversed. When you reverse something, it's just like looking at a mirror image of yourself. You've reversed what you look like, so it's going to end up being a reflection. If you have two congruent figures, you can determine the transformation or the sequence of transformations that maps one figure onto another by analyzing the orientation of the figures. If it's a translation, the length is going to be the same and the orientation is going to be the same, and we can see that happening right there. Everything stayed the same, it just slid. If it's a reflection, the length is going to be the same, but the orientation is going to be reversed. A was on the left, now A prime is on the right. And if it is a rotation, your length is going to be the same and the orientation is going to be the same. As far as the orientation of the letters are going to be the same. I had A, B, C there, and when it lays down, I still have the same clockwise A prime, B prime, C prime. Easy math. Now we want to find out, it tells us triangle ABC is congruent to triangle XYZ. They told us that part. It is congruent. So we know it's going to be some kind of transformation, and we got to figure out what kind it is. To determine the sequence of the transformations for the maps of ABC to XYZ, we're going to compare and contrast them. Well, first off, going clockwise, A, B, C, clockwise, X, Z, Y. So we know there's a reflection going in there because the order of the letters changed. Along with the reflection taking place, there's also a translation where it slid down. Let's see if they're going to let us play with this. Alright, so first thing I'm going to do is I'm going to reflect ABC across the y-axis. So I'm going to do a reflection across the vertical or y-axis, and right there you can see that there's a reflection. That's the first transformation done, and then from there I'm also going to add a translation where my vertical is going to go down 2, and now the two of them are on top of each other. So I recognize two different transformations had to happen, a reflection first and a translation second. Coming down to the bottom of that, it says, so the transformations on to map ABC onto XYZ consist of a reflection across the y-axis followed by a translation 2 units down. Check your answer. That's all there is to it. Once again, it's going to be your turn. Triangle RST is congruent, we know that, to UVW. Determine the sequence of the transformations. Go ahead and work on that one right now. Alright, first thing I'm going to look at here is the fact that I have RS, I'm going clockwise, RST is counterclockwise, RST, and the other one was UVW, UVW is clockwise, so one of them's counterclockwise, one of them's clockwise. That tells me that I'm going to start off with a reflection. So I'm going to take and I'm going to do a reflection across the I'm going to do it across the vertical axis, so it's going to look like that. That's my first step. And now I've got my orientation right. From here, I'm going to take and add a translation. So my translation is going to go up 1, 2, 3, 4, and left 1, 2. So I'm going to do a horizontal translation of -2, a vertical of +4, and right there is going to be our final answer. Scrolling down here, what you would write in this box is exactly what you did, that you reflected triangle RST across the y-axis. After that, you translated it 4 units up and 2 units to the left. And that's all there was to it. We are down to our last pair of problems. Example number 4, Ms. Martin created a logo shown for Diamond Plumbing. What transformations did she use if the letter D is the pre-image and the letter P is the image? Are the two figures going to be congruent? So from there, we're going to take a look at it. I'm going to move through the slides once again to figure out the transformations. And we can see right there that first thing we're going to do is we're going to rotate that P around point A, or the D around point A, becoming a P. And then from there, we're going to translate it up a certain amount. So absolutely, those two pieces are indeed going to be congruent. From there, we can determine the congruence. And determining congruence, it says letters are congruent because their images are produced by a rotation and a translation. The shape is the same size. All there is to it. Don't think there's going to be anything here? Nope, nothing at all. Reset that. And now it is your last extra example. Go ahead and work this one on your own. See if you can get the right answers. Well, the Boyd Box Company uses the logo shown. What transformations could be used if trapezoid A, that's this one, is the pre-image of trapezoid B? That's going to be this one. And you can see that you're not looking at the whole rectangular sides of the box. You're only looking at the trapezoid, the pink part here and the blue part here. So we need to figure out how we're going to take and make A end up being B by identifying some transformations. So first thing I would do is I would say, and they're not even going to give us any toys to work with here, that I would take and rotate A. So I would flip A over, and that would make the orientation the same. And then from there, I would translate it down and over until it matched up on part B. The answer to this question is that both pieces are going to be congruent. That's all there is to it. Now it's time for you to get busy working on your homework assignment. Let me know what questions you have in class tomorrow.